All right, let's get started with 6.5. So 6.5 is theorems about roots of polynomial equations. So a number of new topics coming our way in this one. So here's our vocab down here: rational root theorem, irrational root theorem, and imaginary root theorem. 3 different root theorems. And then we're going to talk about conjugates and complex conjugates. So 2 objectives here. We're going to solve equations using the rational root theorem. And then we're going to use the rational root theorem and the imaginary root theorem. And we won't necessarily solve with those. We're just going to be able to use them. So first things first, let's do some skills checks here. List all the integer factors. Number 1. Okay, so 12 breaks down into 2 and 6. And then 6 breaks down into, let's see, another way it could break down would be 3 and 4, and I forgot the first one. 1 and 12. So the factors are 1, 2, 3, 4, 6, and 12. All of the numbers that go into 12. So see if you can do 2, 3, and 4. And I'm going to have you do 5 actually, because I want to do 6 here. We're going to FOIL all these together on 6. And when you have the square roots here, I'm going to FOIL these 2 together first. Because if you'll notice, this is a plus b and a minus b. It's the exact same things. X with x, root 3 with root 3 with a plus and a minus. So that works out. We'll leave the x plus 2 out front. To x squared minus root 3 squared, which is just 3. And from there we can FOIL. We'll end up with x cubed. And then we'll get 2x squared minus 3x minus 6 when we FOIL all the way out. All right, and for 7, 8, and 9, I'd like you to look back in 5, 6, I believe, here, and figure out what the definitions of rational, irrational, and imaginary are. So go ahead and pause the video, finish those up, and when you're ready, we'll keep moving with 6.5 here. All right, rational root theorem. So what we're looking at here, this is a complicated way of saying, take the factors of your constant term, all right, all the factors. And we're going to list those out, and we're going to call those P. All right, so P factors of the constant term, and we're going to call that the trailing term. All right, Q is going to be all the factors of the leading term. All right, everything that starts up front. Factors of the leading and just the coefficient. And that should be the same up here. Leading term's coefficient. Coefficient. All right. So the only factors of the polynomial are plus or minus P over Q. All right, so we'll deal with that in a second. But you take P, all the factors of the trailing terms, divided by Q, all the factors of the leading terms coefficient. So let's take a look and see if we can use that to find all the rational roots. So trailing term, coefficient's 3. So what are all the factors of 3? Just 1 and 3. So P is 1 and 3. What about our leading coefficient? That's just 1. There's only one factor of 1, and that's 1. So all the possible factors are plus and minus 1 over 1 from here and 3 over 1. Right? All the combinations. So that's just the same as saying plus or minus 1 and 3. And we're going to figure out which of those are rational roots. So the way we're going to do that, let me erase this for some space. At this point, we know that plus or minus 1 and 3 are the only possible factors. So let's do some synthetic division and see which one of them come out. So we've got 1, 1, -3, and -3. Let's start with -1. So 1, negative 1, 0, 0, negative 3, and 3. Hey, negative 1 comes out, so negative 1 works. Okay, how about positive 1? 1, 1, 2, 2, negative 1, and negative 1. Nope, negative 1, or positive 1 does not work. How about negative 3? 1, negative 3, negative 2, and 6, and 3, and negative 9. So, didn't finish this. This is negative 4. This is negative 12. Negative 3 doesn't work because we have to have 0 here for it to be a factor. And the last one to check is positive 3. And we get 1, and 3, and 4, and 12, and 9, and 27, and 24. Nope, doesn't work either. So there's only one rational factor, and that is negative 1. All right, so the rational root is negative 1, and we can write that as x plus 1 if we were writing it as a factor. All right, so you're up. See if you can figure out the rational roots of x cubed minus 4x squared minus 2x plus 8. All right, now we're going to find all the roots, rational and otherwise, on this one. So, all the factors of 1 are just 1 and 1. All the factors of 2 are 1 and 2. So, factors are plus and minus all of these combinations. So, it's going to be plus or minus 1 and 1/2. All right, so we need to find one that works. So, we'll do some synthetic. 2, negative 1, 2, and negative 1. And let's start off with the smallest one, negative 1/2. Let's see what happens. 2, that's going to be negative 1, that's going to be negative 2. Half of that is 1, that's 3, and that's negative 1/2. Nope, that doesn't work. How about positive half? 2, and negative 1, 2, and negative 1. And we've got 1, and 0, and 0, and 2. And 1, hey, look at that. So, we've just factored, and we've got x minus 1/2. And now what do we have left over? We've got 2x squared plus 0x, so I'm not going to write that, plus 2. All right, this equals 0. We know one of the factors already is 1/2. We're going to keep that. We don't need to go through synthetic anymore because we can just solve this one. Anytime you're down to squared, we have tools to solve that. Let's set it equal to 0 and solve. Well, minus 2. So 2x squared equals negative 2. X squared equals negative 1. We're going to square root both sides. And so x equals plus or minus. What's the square root of negative 1? I. There's 1, 2, 3 solutions, and that's how many we should have. Half, and then plus or minus I. Those are all the roots of the polynomial. All right, so same steps. For number 2, understanding check, do A and B. Okay, so now that we know the rational root theorem, let's bring in the irrational root theorem. All right, and so before we do that, we need to know about conjugates. All right, so if we have a quadratic, like x squared minus 4x minus 1, the solutions are 2 plus root 5 and 2 minus root 5. And so anytime you have a pair like this, where it's a plus a root and a minus a root, they're going to be conjugates. All right, and when they have, and we'll know this in a little bit, but they come in pairs. Plus and minus is the only thing that changes. Notice the 2 and the root 5 and root 5 will match. All right, those are the pairs. So here's the irrational root theorem. Let a and b be rational numbers and root b be the irrational number. So if a plus root b is a root, then a minus root b is also a root. Has to come in pairs. All right, so let's take a look. A polynomial equation with integer coefficients has the root 1 plus root 3 and negative root 11. Find 2 additional roots. All right. since we're going to have conjugates and they have to come in pairs, we know that the other roots are going to be 1 minus root 3. And then also, this is the same as saying 0 minus root 11. We could say 0 plus root 11, or just positive root 11. And those are the other two roots. Just that simple. Just finding the opposite of the pair. All right, so answer understanding check 3 with that in mind. Okay, and so now we're going to add in the complex conjugates using imaginary numbers. It works the exact same way. If you have a plus some amount of imaginary numbers, you also have a minus some amount of imaginary numbers as roots of polynomials. Those are complex conjugates. So, if we know that 3 minus I and 2i are roots, we also know that 3 plus I and negative 2i are also roots, just by complex conjugates. All right, so we're always going to have the opposites. So, see if you can find the answer to understanding check 4. All right, last example here. So we can put all of this together to solve when we have some irrational or imaginary roots. So find a third degree polynomial with the rational coefficients that has roots of 3 and 1 plus I. All right, so we know that our factors are going to be x minus 3 because of the 3. And we also know we're going to have x minus 1 plus I, because it's always x minus the root, and x minus, which one is missing? Well, it's got to be 1 minus I. All right, and so now we need to multiply this all the way out. So I'm going to start with this, x minus 1 minus I, and I've also got x minus 1 plus I, and so let's multiply that out. And we'll have x squared minus x minus ix minus x plus 1 plus I, and then we'll have ix, and we'll have negative I, and we'll have negative I squared. And so let's put all that together. I'm going to keep the x minus 3 out here. And so we've got x squared minus 2x. The ix's cancel, the i's cancel, plus 1, and then I squared is negative 1, so negative I squared is plus 1. So that plus that is plus 2. And so we'll have to FOIL, not FOIL, but distribute again. And let's see what we get here. X cubed minus 2x squared, 2x minus 3x squared, 6x, and negative 6. So put it all together. Our final answer is x cubed minus 5x squared plus 8x minus 6. All right, a few steps on that one. Got to keep track of your algebra, but if you do it right, I think you can get the answer here for 5A and B. Give it a shot. You're all done with 6-5, and any questions, we'll go over it in class. Good luck.